Hello my dear students, welcome back to NEET World. So we will be discussing haloalkanes, okay, and this session is for all the students who are preparing for EAPCET 2026 as well as NEET JEE exams, okay, right. So in the last session we have covered about SN1 reaction, right, nucleophilic substitution reaction, that is unimolecular nucleophilic substitution reactions, and I have given the applications as well as PYQ questions related to that topic from JEE, NEET and EAPCET exams, right. So in this session we will be discussing few more questions related to SN1 reaction. After that I will be explaining you SN2 reaction, okay. Once after discussing this SN2 reaction, we will solve some questions related to it. Then we will be discussing about E1 and E2 reactions. What is this E1 and E2? These are elimination reactions, okay. Like substitution reactions we have SN1 and SN2, right. So in the similar way we have E1 and E2. We will be discussing this and comparing SN1 SN2 with E1 E2 reactions, okay. How do we decide the reaction? All these things will be discussed in the session, okay, right. First of all, let us have a look on the previous, some previous year questions of this SN1 and SN2 related questions. See, this is a question from EAPCET. The question says the organic halide which does not undergo hydrolysis by SN1 mechanism. It means from the given 4 options which will not undergo hydrolysis by SN1 mechanism. See, what do we mean by SN1 and SN2? It's a nucleophilic substitution. Now, for example, there is something like this. See, there is some alkyl group here, okay. There is a carbon on which alkyl groups are there, and let us say one halide ion is there, okay. So now what happening here? So some nucleophile will come. This nucleophile will replaces this halide ion. So here it is a leaving group. It will goes out and a new group will enters onto the carbon, right. Therefore you are going to get a new product something like this, R. So what is the difference between the reactant and product? There is only one difference. There is this leaving group. This X is a group, leaving group I can say, is replaced by this nucleophile. See, one group is substituted by other group now, right. So that's why we are saying one nucleophile is substituted other nucleophile. We are calling it as nucleophilic substitution reaction. Hope the discussion is clear. So now it is in SN1 reaction. It means only reactant concentration is taken into the rate equation. Now which of these will not undergo this nucleophilic substitution reaction, that is SN1 reaction particularly? See, those compounds which does not, see here, if you see what is happening from this reactant, first this group will goes out, this X group will goes out, so that you will get a carbon. See, on this carbon halogen is there, like leaving group is there. Out of these two, which is more electronegative? Most generally this leaving group will be only the electronegative atom. Let us say it is a halide ion, so it will be halogens are more electronegative than carbon. Therefore the bonded electrons will be taken by the halide ion only, so it will goes out as a halide ion, X minus. Now what is the charge creating on this carbon? It will be positive charge. Now how many groups are there? There are 3 groups here. So one R group and second R group, and this is third R group. Like this you have a carbocation generation, okay. Now on to this carbocation we are having a nucleophile that is entering, right. So what is a intermediate formed in SN1 reaction? It is a carbocation. Now this nucleophile will attack on this carbocation and gives you this final product, okay. And I told you stereochemistry also, if this is a chiral center here, then you are going to get a racemization product, right. Now so now look at this. If this formed carbocation is more stable, then SN1 reaction will be very faster, okay. The rate of this reaction is very faster if this intermediate stability is more, okay. Now look at this. If this intermediate is formed intermediate is highly unstable, then that reaction won't take place, okay. So for example, in the first option here you have benzyl chloride. So look at the thing here, just try to remove this chloride ion from here, so that you will get CH2 plus here. So this is a benzyl carbocation. See, we know benzyl carbocations can be stabilized by resonance, mesomeric effect of this pi electrons from the aromatic ring, right. Now so it means this is a carbocation forms which is a stabilized carbocation, so it can participate in SN1 reaction. Now they are asking does not undergo hydrolysis. It means, what do we mean by hydrolysis? in the place of chlorine, we are treating that compound with water. So in the place of chlorine, this oxygen will attach from the water onto the carbon, so chlorine goes out. Okay, so that final product will be what? So it will be benzyl alcohol, CH2OH will be your product. Yes, that is happens in first reaction. In a similar way, if I look at the second compound here given, allylic chloride is given, CH2, CH2 plus charge, here it will be created. Why it will be created plus charge? If you observe this, here methylene like CH2 chlorine is there. So if I remove this chloride ion with a negative charge, now what happens? Onto this carbon you are generating a positive charge right now. So this positive charge can be stabilized by the pi electrons which are in conjugation here. So here also we have more mesomeric effect that can be stabilizing this carbocation like conjugation like this. Okay, you will get CH2, CH, CH2. See, if these pi electrons are shifting here, so you are getting here shifting of this pi electrons, and this carbon is losing now, so you should place a positive charge on that carbon. That's it. So this is how this positive charge is distributing among these carbons. It means the charge is distributed among these charges means, see, initially it is only on this carbon. Due to the shifting of this charge, that is what spreading of this charge, the stability increases. Why? Because this positive charge, if there is no spreading, like there is no conjugation, now what happens? Only one carbon will experience more electron deficiency right now. Now what these electrons are doing? Yes, by usage of these electrons, it is helping the carbon. It means it is stabilizing that electron deficient carbon by the conjugation. So this is how allylic carbocations are stable. So it means B also participate in hydrolysis, that will undergo SN1 reaction. Now look at this third option. If you observe third option, so it is see, carbon having chlorine here, this side one methyl group, and there are 3 methyl groups like this. So it's a tertiary halide we have. Okay, so if I remove this chlorine atom from here as a chloride ion, now what happens here? The central carbon will get a positive charge and 3 methyl groups are there around it. Okay, so now what happens, tell me? This is an sp2 carbon, so having 3 methylene groups with electron deficiency here right now. So how many alpha hydrogens are there? Here 3 plus 3 plus 3. So 9 alpha hydrogens are there. It can be stabilized by hyperconjugations. How many hyperconjugation? 9 hyperconjugation possibilities are there. 9 hyperconjugative stabilizations are there here because of this alpha hydrogen. So this carbocation is also highly stable. So it means it will also involve in the reaction. There is only option left here with us, that is option D. So now try to remove this chloride ion from here. So if you remove that chloride ion, see, you are going to get CH3, CH, double bond CH2 onto this carbon will have a positive charge. See, remember, whenever there is a double bond with positive charge, we should call it as a vinylic carbocation. What is that? Vinylic carbocation. So these vinylic carbocations are highly unstable. What I am saying? These are highly unstable. First of all, they won't form like this. Why they won't form? Because instead chlorine taking this electron, what happens here is the lone pair electrons present on the chlorine itself is in conjugation this with pi electrons, because see, lone pairs, sigma bond, pi bond. So those are in alternate position, right? So now what happens? This sigma electron, like lone pairs, will be in conjugation with these pi electrons. So this is how resonance is taking place. So initially if you see, only sigma bond, one single bond is there. Now due to the conjugation, it is becoming like a double bond character right now between the carbon and chlorine. Therefore, if double bond is forming, see, more the number of more bonds, more is the stronger will be the bond strength. So chloride ion will not comes out here. So it means it will not involve in SN1 reaction. So it will not undergo hydrolysis. So what will be your perfect answer for the question? Option D will be your perfect answer. Now let us generalize some statements so that you can directly do during the exam. So what is the first statement I am mentioning here is, see, I just wanted to mention, yeah, just give me a minute. Yeah, so the first statement I want to mention here is, here I just mentioning this point, just see here what I am writing. Vinyl halides, it means these are the compounds which are generating this type of carbocations, like these are vinyl halides and aryl halides. Aryl halides means what? You know benzene ring, right? This you can say also as aryl group or phenyl ring. Okay, on this if direct halogen is attached, you can say them as aryl halides. So vinyl halide, aryl halides does not involve in SN type reaction, whether it is SN1 or SN2, they won't involve in this nucleophilic substitution reactions. Just remember this. Okay, because respect to carbocation formed is highly unstable, or the chloride ion itself won't comes out easily. Okay, I can say it is an inert. Okay, so it's an inert halogen compound I can say, whereas this can be considered to be labile because they are participating in the reaction, right? So chloride ion coming out, so you can say them as labile, whereas this one as an inert halide ion. Okay, halide compound, halogen compound. Okay, hope the discussion is clear. Guys, if the discussion is clear, just hit on the like button, and if you are new to this channel, please click on the follow button, I mean subscribe button here. Okay, right. If there is any confusion in the discussion, please let me know in the chat box. You can feel free to write in the chat box. I will be looking into it. If you want any clarity, I will be explaining it. Okay, right. Next thing is here, we will be discussing, yeah, let me give you few more questions first. Yeah, based on our discussion, whatever we discussed till now, based on the discussion, the 2 points you have written at the end of the discussion for the previous question, using that you can easily solve this question. Tell me what will be your answer. See, if I remove this chloride ion out, what happens? Aryl group, this phenyl ring will get a positive charge, that is highly unstable now, so it won't comes out. Similarly, if I remove this chlorine, will it comes out? No. Why it won't comes out? Because the lone pair electrons of this chlorine is in conjugation with the pi electrons of this carbon chain. Right now, again this is in conjugation with the ring pi electron. Therefore, what happens? This single bond here which is present between chlorine and carbon is getting a partial double bond character by the conjugation. So therefore, the single bond become double bond right now, like almost a double bond, because partial double bond character we are getting by the resonance. So due to this reason, the bond strength is getting increased, right? So if bond strength is increasing, we cannot able to remove this chloride ion. It will be strongly hold to the carbon here, so it will not comes out. Okay, right? Is this clear? So I can say this as an example of vinyl halide. What is that? It's an example of vinyl halide. So vinyl halides, and this is an example of aryl halides. So just now I told you vinyl halides, aryl halides does not participate in SN type reactions, right? So now look at here, they are asking here number of moles of AgCl is formed. How it will be considered? See, we have here AgNO3, means from here Ag plus ion, from here you are going to get a chloride ion. Together they will form AgCl. AgCl is a white precipitate, right? So they are asking number of AgCl is formed in the following reaction. See, they mentioned X AgCl precipitates. So what is the value of X? So now if you remove this, yes, this is possible. This is nothing but, look at this carbon. So this carbon is called benzylic carbon. In the previous question, the first option I told now, benzylic carbon, yes. So if I remove this, we will get a positive charge over here. That positive charge can be stabilized by ring pi electrons. Yes, so it means you can remove this chloride ion easily. So it will form precipitate with AgNO3 and forms AgCl precipitate, right? So this chloride ion can be removed. Similar way, if I remove this, right? So this carbon is a tertiary carbon, right? We have methyl group over here, and there is 2 hydrogens here. So it can be stabilized by 6, 3 plus 3, 6, 7, 8 alpha hydrogens are there. So 8 alpha hydrogens are there. 8 hyperconjugations are possible for this carbocation formed. So both chloride ions can comes out, and it will be forming 2 AgCl as a precipitate. Okay, 2 AgCl precipitates will be formed. So how many moles it is forming as AgCl? So 2. So this is how you need to answer the question. Hope the discussion is clear, right? Guys, if this is clear, please hit on the like button, or if you have any confusions, let me know in the chat box. I am looking into it. Guys, is this clear or not? Anyone in the chat box can express, is this clear or not? Right. Let me give you a few more examples here. Yeah. look at this. Which of the following compound is inactive towards SN1 reaction? So let's just try from your side. This is a JEE main question. So try from your side. If you are unable to get, you can watch my yesterday's live session on discussion of SN1 reaction, because already I explained this type of examples in the last discussion only. So just try. If you are unable to get, you can after this session you watch in the yesterday's session. Okay. So now let us begin our discussion on SN2 reaction, nucleophilic bimolecular nucleophilic substitution reaction. Okay. So what I am discussing today, bimolecular nucleophilic substitution reactions. Okay. So here what you need to know, first of all, reactivity order. So during this bimolecular nucleophilic substitution reactions, primary alkyl halides or primary alcohols, this kind of compounds will readily participate in this bimolecular nucleophilic reaction. Why they will readily participate, I will explain. Just write these statements first. So primary alkyl halides, secondary alkyl halides are more reactive compared to the tertiary alkyl halide. This is a reactivity order. Okay. So the next one here is you need to remember this rate of this reaction. If I say Rx combining with some nucleophile forming some product here, okay. So rate of this reaction depends on both concentration of substrate as well as concentration of this incoming nucleophile. So in the rate determining step, both our substrate as well as nucleophile are involving now. So the rate of this reaction, order of this reaction is 2 here with respect to substrate 1, with respect to nucleophile is also 1. So total order of this reaction is 2. Okay. So it means what is happening, just look at the mechanism I am writing here. See, I am taking a primary methyl group here. You just take a methyl halide, not even a primary, it is simple one. Okay. So methyl chloride I am taking. So I am adding to this, and let us say I am adding a nucleophile. So now what happens here? So look at this carbon in the substrate, then sp3 carbon, right? So sp3 carbon means you can write 3 hydrogens in this way, right? After writing this, it's an sp3 tetrahedral geometry. Now what happens is, this is an incoming nucleophile and a chloride ion is a leaving group here. Okay. So the attack of nucleophile as well as the leaving group goes out simultaneously. This process happens at a time, like simultaneously happens. So now what happening? So you are seeing carbon at the middle and 3 hydrogens are there like this. So this chlorine atom going out like this, and incoming nucleophile is entering at the same time. So nucleophile is coming in. Okay. So this is what the scenario you will be seeing right now. So you can see incoming nucleophile coming and chloride ion going out right now. So this process takes place simultaneously. If you observe properly, nucleophile is not coming exactly as like in the position of this chlorine, but it is coming exactly from the opposite side right now. So why it is coming from opposite side? Because here chlorine is nucleophile is having electron density, and our chlorine, the leaving group, is also having more electron density. If this both like charges come each other, what happens? Repulsion takes place now. So that's why it will avoid to come from the same plane, and it will comes exactly from the opposite direction, so that it will not experience repulsions by this leaving group, right? So that's why it is coming exactly from opposite side. Now if it is coming exactly from opposite side, what is happening here? Right, slowly this goes out, and this nucleophile will make the bond perfectly, so that you will get carbon with these 3 hydrogens in this manner and a nucleophile over here like this. Okay. So this is called umbrella inversion. What I am saying? Umbrella inversion. Sir, you are saying umbrella inversion once again. Please repeat the concept if means. Okay, I will explain you once again. Listen to me. See, I told you the reactivity order is primary halide more, then secondary, least is tertiary. I told you. Why I told you? See, here nucleophile is entering right now during the reaction. What is coming here? Nucleophile is coming. So the entry of nucleophile is very easy if these attached groups are very small. If these attached groups are small, nucleophile will enter smoothly, okay, easily, okay. So due to that reason, primary is more reactive than secondary is more reactive than tertiary, okay. This is what you need to understand first, okay. Once it is allowed to enter here easily, then reaction proceeds forward, okay. So this is called transition state. What I am calling? Transition state, TS, transition state, you can remember, okay. Now I used a word called umbrella inversion. What is that umbrella inversion? Let us say these three groups, hydrogen I have written now, let us differentiate them, hydrogen 1, hydrogen 2, hydrogen 3, okay, or let us say them as three different groups, okay. Around this carbon, now there are four different groups. What are the four different groups? 1, 2, 3. These are three different groups. This chlorine is fourth group right now. So due to these four different groups, now the carbon, if there is four different groups around the carbon, you can say that carbon as a chiral carbon. What you can say? It's as a chiral carbon, okay. So whenever there is a chiral carbon involving in the SN2 reaction, what happens is on each chiral carbon, let us say I am prioritizing these groups based on their atomic number. Let us write it clearly. Now what I am writing, see here what I am writing, carbon I am writing, here we have a chlorine atom, okay, and here I am writing hydrogen, that is let us say to differentiate this, I am saying this is a protium, okay, this is a deuterium D, that is 2, okay, H2, and tritium, that is H3, that is T I am writing, okay. So you understand like this. There are four different groups now. So yes, you can say this as a chiral carbon. Now this carbon is a what? Chiral carbon. Now assign their priority orders. Let us say this group is above the plane. What I am saying, this chlorine is above the plane and our hydrogen is below the plane like this. Okay. Now I told you about RH nomenclature in the last class. Anyways, I will be explaining here once again. Please follow me. See, chlorine is most like based on their atomic numbers, prioritize this group which is having highest atomic number here. So chlorine, right? So this is considered to be 1. Again, between these three, all of them are isotopes of hydrogen. So atomic number is same, but they do have different mass numbers, right? So the mass number is highest for which one? Tritium. So this should be 2 and this is 4, and our hydrogen atom protium is protium is 4. This is 3, this is 4. That's it. Okay. Now go from 1 to 2, 2 to 3 like that. So how it is? So it is like this now. So which direction it is? It's a clockwise direction now. So then you can say it's an R configuration isomer. What I am saying? If the configuration is R, like if the direction from 1 to 2 to 3 is clockwise direction, then you can say it is an R configuration. When you are saying this is clockwise direction, our least priority group should be, this fourth priority group should be on below the plane, like dashed line below the plane. Then if it is clockwise, you should say R direction. If the least priority group is on above the plane with this clockwise direction, you should say it as an S configuration. There is something called RS configuration. How it is? It is clockwise direction now. So you can say it is R configuration substrate. Now when the reaction is taking place, now what is happening in the place of chlorine? From the opposite direction, we are getting this nucleophile. It means now nucleophile will be coming, see this is above the plane now, so our nucleophile will comes from below the plane. So here it will be coming from below the plane like this. Now what happens? Starting material having R configuration. Now product, see product formation, what happens? It will be having S configuration. Why I am saying S configuration? Because nucleophile is coming exactly from the opposite direction, right? Now above the plane become below the plane. That's why if it is R configuration, our product will be S configuration. See, configuration inverting or not, R becoming S, S becomes R in this SN2 reaction. Okay, so that is what inversion of configuration takes place. What I am saying, inversion of configuration, takes place in SN2 reaction, whereas in SN1 reaction, what I told you, racemization, like partial racemization takes place. Okay, so these are the two important statements to be remembered for exam purpose, okay, I mean for understanding the concept purpose. Okay, is this clear? Okay, hope this discussion is clear. Now let us do some questions. See, when I told you in SN1 reaction, what is the intermediate you have seen? SN1 reaction, carbocation. Okay, so there is no such intermediate in this SN2 reaction, because SN2 reaction is a single step reaction. It is what? A single step reaction. See, it is taking place in a single step, right? Whereas SN1 reaction, first substrate forms carbocation, then carbocation converts into product. Okay, that is a multi-step reaction. You can say SN1 reaction as a non-concerted reaction. What I am saying? This is a non-concerted reaction, whereas SN2 reaction is a single step reaction. You can say concerted reaction. What you can say? It's a concerted reaction. Okay, and you will be having, it's a single step reaction now, so here you will be seeing only transition state. Okay, that's it. Now they will ask you one very small and interesting question. What will be the hybridization of carbon in the transition state, they will ask. Okay, so the hybridization of carbon in the transition state is sp2. Just remember, what is the hybridization of carbon in transition state formed in the SN2 reaction? sp2 carbon is a hybridization for transition state carbon. Okay, sp2 is a hybridization of carbon here in hybridization. Okay, remember this. Okay, it's a very important point. Okay, the next one is this reactivity order they will ask. That is also fine, done. Okay, and if you see, the electron density on this carbon will be more. See how many electrons you are seeing? There are 3 perfect bonds by the 3 hydrogen atoms, the pink color bonds, right? Now along with that, here we have partial bond character, this side also partial bond character we have right now. So due to that reason, the carbon experiences more electron density. So in the transition state, carbon experiences more electron density. So due to that reason, in order to make transition state more stable, we need a group attached to the carbon which withdraws the electrons towards itself from the carbon, because carbon is having more weight, electron density is more due to the presence of this many bonds. Okay, because already having 6 electrons with this pink color bonds, now with this hydrogen, just I am highlighting in that way, and this is partial bond characters are there now. Due to that reason, carbon is holding more electron density. Now we require some groups to be attached to the carbon that withdraws the electron density from the carbon and stabilizes the carbon in the transition state. So now what I am making is, I am making a simple statement: electron withdrawing group containing alkyl halides readily participate or more reactive in SN2 reaction, or I can see electron withdrawing groups increases rate of SN2 reaction can be increased by electron withdrawing groups, because what I told you, in the transition state the carbon will be having more electron density. So to decrease that electron density, what type of groups required? Electron withdrawing groups are required. Okay, this statement to be remembered. Now I will be giving you few questions related to this. Hold on for few more minutes. Let me add one more statement for SN1 reaction also. See, what is the intermediate formed in the SN1 reaction? It's the carbocation, right? It's an electron deficient. This is electron deficient. See, if this is electron deficient, now what type of groups increases the stability of carbocation? Right. So electron releasing groups increases rate of SN1 reaction. Okay, please remember these differences. If it is electron withdrawing groups, rate of SN2 reaction is increased. If it is electron withdrawing group, SN2 rate increases. If it is electron withdrawing group, electron releasing groups, that increases rate of SN1 reaction. Let us make it more clear using the example. Standard example let us take. See, this type of questions you will be experiencing in the exam also. Please try to understand. If there is any confusion, let me know in the chat box. Feel free to discuss with me. See here what I am writing. See, I hope you already got some clarity on GOC part. If not, please watch my previous lesson, sessions on this GOC, General Organic Chemistry. That will be highly helpful to make your organic chemistry stronger. If you know the GOC, most of these questions will be like you are going to do like this, very smoothly you are going to do, because you need to identify what type of groups attached here, whether it is electron withdrawing group or releasing group, whether it plays mesomeric effect or hyperconjugation or inductive effect. These kind of applications are very, very important. If you know that concepts only, then you can survive here. If not, then it is very difficult to understand the concept for the chemical reactions of organic reactions. Whatever the chapters there in the class 12th organic chemistry completely depends on what your 11th organic, that is GOC part, particularly GOC part. If you are get strong command over that GOC part, yes, you can play with organic chemistry like anything. Okay, without even knowing chemical reactions, you can perform your own reactions by looking at the given substrate and nucleophile or whatever the reagent they given. Yes, you are going to write the product just by looking at the reaction, if you know the GOC part strongly. Okay, right. Let us look into this. See, I am saying rate of SN2 reaction. What is the question I am giving you? Rate of SN2 reaction in the 4 options. Let us say A, B, C. These are the 3 options I am adding. Tell me which is more readily involved in SN2 reaction. This is a question. Okay. So what I told you, rate of SN2 reaction increases with the help of electron withdrawing groups. So now what type of group attached here? This is a releasing group, electron releasing group. What about this group? It is an electron withdrawing group, right? So you got the concept now. See, when chloride ion goes out, a nucleophile attacks here. That's what I mean. Like SN2 reaction means what? Substitution of this leaving group by nucleophile. So that will be faster when we have electron withdrawing groups. So here we have electron withdrawing group, that increases the rate of SN2 reaction. Therefore, C will be more reactive, involves faster in SN2 reaction. And then next here, electron releasing group is there. So no, electron releasing groups decreases the rate of SN2 reaction. Only electron withdrawing groups increases the rate of SN2 reaction. There is no such group, so it means C will be more. There is no group, sir. Is better than having this electron releasing group, okay, in SN2 reaction. So this will be the correct answer for SN2 reaction. Which reaction? For SN2 reaction. Now the same options are given for SN1. Now rate of SN1 reaction for the 3 options. Tell me which is more readily involved in SN1 reaction, they will ask. Now tell me, we know in SN1 reaction carbocation is formed as an intermediate. It is formed as an intermediate. If this carbocation is intermediate, we know it is electron deficient. What it is? It is electron deficient. If this is electron deficient, carbocation intermediate is electron deficient, that electron deficient species only requires electrons. So if carbocation is formed here, we need a group which will releases electrons into ring that will stabilize this carbocation. So here we have electron releasing group now. Yes, electron releasing groups increases rate of SN1 reaction. So which increases rate of SN1 reaction? Electron releasing groups. But if it has electron withdrawing groups, that decreases rate of SN2 reactions. Okay, rate of SN1 reaction, sorry. Electron withdrawing groups decreases rate of SN1 reaction. That's it. With these two statements, you can give the order now. What happens? A will be more reactive than B because B has no group, but C has electron withdrawing group, that will be least reactive here. So this will be the order. So this will be the order for SN1 reaction rate. Okay. So now look at these 2 comparisons. This will be exactly opposite to that now. Right. Both of them have different answers for same options because it is SN1 depends on carbocation stability, SN2 depends on what type of groups attached to the ring. That's it. Okay. Guys, is this clear? Whatever we discussed till now, is this clear or not? If the thing that we discussed till now is clear, please click on the like button, and if you are new to this channel, follow us. I mean, just click on the subscribe button also, and you can share with your friends who are seriously preparing for EAPCET, JEE or NEET exams. Okay, and if you are looking for IP preparation and if you want any help from us, yes, we are already making free live sessions for IP exams also, like both Telangana and AP students who are preparing for IP can watch all the live sessions that are conducted for IP sessions separately. Every day we will be making live for both first year and second year. Just go through the live playlist and you can watch all the subjects, mathematics, physics, chemistry and biology. All these are there. Yes, you can watch them if you want it. Okay, right. Let us continue our discussion on this. See, now yesterday only I have explained about this, no need of discussing again. Now look at this. What I am going to show you here, see, during the reaction, during this nucleophilic substitution reaction, what we have seen, there will be halide ion or some living group will be there on the carbon, okay, and we are adding some nucleophile here. So this is a reagent. Now what happening finally, that living group here, let us write L. L means living group, let us consider. Okay, this living group will be replaced by this nucleophile, right? So RCH2 Nu we are getting. This is what the transformation we are seeing. This is what the substitution taking place. So if our reagent here, the nucleophile reagent is something from here. See, if it is OH group, now what happens if this is OH group? They simply mention the nucleophile as NaOH, KOH, like that. Or they will mention aqueous, KOH, aqueous, NaOH they will mention. Okay. Now what will be the product formed? You are going to get alcohol as a product. Okay. Substitution product is what? ROH. The name of that product is alcohol. Okay. Try to remember this. Try to understand this. See, nothing to remember here. Just understanding the concept is enough. No need to remember anything here. Just by looking at the reaction itself, that comes, that will strikes in your mind when you understand the concept. See, if this is a some living group. Now I am using OH minus. Now what happens? So yes, is there any blur on the screen? Yes, if there is any blur, please mention in the chat box. I will make it correct. Now what happens, tell me? So this will attacks over here and living groups goes out. You will get R, CH2, OH. What it is? It is an alcohol only, no? So it can be aqueous form of KOH, NaOH or some other bases like aqueous CaOH twice, like that you can consider. The next, it can be simple water also. You will be getting alcohol as a product. If it is alcohol itself is a nucleophile, like alkoxide ion is a nucleophile, like OR minus. Now what happens? OR minus means this is a carbon attached to the oxygen, so this is attacking on the carbon. So carbon between oxygen, that should be called as ethers. What you can call? Ethers, like ROR will be the product formed here. Then next, if it is sodium iodide, like iodide ion is a nucleophile, if that is attacking on this carbon, now what happens? You will get RCH2I, that is nothing but alkyl iodide. So alkyl iodide will be the product formed. Similarly, if ammonia is the nucleophile, then you will get amines. What you will get? Amines. That is primary amine, you will get the first product. Okay. So the next, if primary amine is acting as a nucleophile, then you are going to get a secondary amine as your product. If secondary amine is acting as a nucleophile, then you are going to get a tertiary amine as your product. Okay. So everything that we are discussing here is very easy and understandable only. If there is any confusion, please tell me. Please tell me if there is any confusions. Right. If no confusion, let us move forward. Let us move forward if no confusions. Yeah. So see here, if KCN, yeah, understanding this is very, very important. See here it is given as KCN and this is given as AGCN. See, between KCN, this is an ionic compound. KCN is an ionic compound. Remember, whereas AgCN is a covalent compound. What I am saying, it is a covalent compound. So the structure of KCN will be like, you can understand it like this in aqueous medium. It will be K plus and Cn minus. When it comes to AgCN, so there is a bond between Ag and carbon, like cyanide, like carbon is bonded to the covalent bond with the silver. Okay, like this it will be there. So now if you understand this, if you see this, which is less electronegative between carbon and nitrogen, carbon is less electronegative now. So during the substitution reaction, which will be the reactive site, the less electronegative site will be the reactive site. So it means if I want to do a reaction with this this substituent, so what happens, this less electronegative carbon only attacks on the carbon, therefore you are going to get a cyanide type of product, RCN type of product. So what is the product formed here? RCH2, Cn will be your product, cyanide will be the product, okay, cyanide, nitrile or cyanide will be your product formed if it is taken as KCN, like ionic compound like KCN, NaCN is taken. But if you take AgCN, see the carbon is not free here, this is already combined with the silver, that is having covalent bond. So due to this reason, our carbon is not the reactive site here, nitrogen will be our reactive site in the reaction. Now if you do the reaction, RCH2, some leaving group is there. Now which group will be attacking on this? So the nitrogen will be attacking here. So like leaving group goes out. So you will get a product like RCH2NC. Okay. So here it is Cn, here it is NC. Here nitrogen attached to the carbon, but in this case carbon attached to the carbon. Okay. So you should call it as isocyanides. What you should call? Isocyanides. And now look at here, when it is AgCN is our nucleophile taken, reagent taken, you are going to get isocyanides, isonitriles, isocyanides as the product formed during the substitution reactions. Hope the discussion is clear here. Okay. Next one is KNO2. The same explanation will be there here also. When you take KNO2, that is KNO2. So in this case also, nitrogen double bond O and oxygen single bond and oxygen with a negative charge K plus. Like this we will be having nitrogen with the lone pairs. Okay, this is one thing you need to remember. And one more thing is AgNO2. So nitrogen at here double bond O and oxygen with silver here, like this, and nitrogen having lone pairs. So these are the scenarios to be remembered or understand here. Okay, now look, what is the free site here? Nitrogen, here it is free site, oxygen also free site. So when it is reacting with any substrate like this, so O minus, like negative charge oxygen will be attacking here because of more electron density. Okay, so it will be forming a compound like RCH2ONO type product. When it comes to here, see oxygen is not free now. Okay, both of them are having lone pair electrons, there is no charge on oxygen to attack. So there is only less electronegative nitrogen to attack here. Okay, see even oxygen can also attack, but which is less electronegative here? Nitrogen now. So it will be having more tendency to donate when I compare with the oxygen. Okay, so RCH2 L, if I take leaving group, so nitrogen only attacks here, leaving group goes out. So you will get RCH2NO2, here it is ONO, there it is NO2. Okay, so if I take KNO2 or NaNO2, your product is alkyl nitrite. Okay, what is that product? Alkyl nitrite, like ONO. Okay, ONO, RONO is a product. Okay, if you take a covalent compound like AgNO2, so it will be, what it will be forming? It will be reacting with this one, nitrogen. So we will get a nitroalkane product. What you are going to get? So this nitrogen only reacts. Okay, nitroalkane RNO2. This is RONO2. This is ONO2, like ONO in case of KNO2, and it is NO2 in case of AgNO2, covalent compound here. Okay, so nitroalkanes are formed when you take covalent compound. Guys, whatever we discussed from the last 10 minutes, this is also one of the interesting factor to be remembered when you are talking about nucleophiles. Okay, attacking sites of nucleophiles. Yes, directly you can expect from last 10 minutes discussion also. You can expect a question from last 10 minutes discussion, whatever we did for KCN, AgCN, KNO2, AgNO2 discussion. Okay, right. Then next, if you use lithium aluminum hydride, then hydrogen is our nucleophile. Okay, then you will get respective alkane as a product. Okay, and if you use silver salt of carboxylic acid, you will get esters as your product. Okay, try to remember the discussion, try to understand the discussion, and you can predict your own product during the chemical reaction, substitution reactions. Okay, right. So this is about the discussion, substitution reactions. Okay, then next we have elimination reactions. What we have next is elimination reactions. So what do we mean by elimination reaction? During a chemical reaction, during a chemical process, for example here what I am writing, just try to understand what I am writing here. See, elimination reactions means we are eliminating something from our substrate. Let us say okay, there is something like this. This is our substrate. Okay, so here I am using something called base here. Okay, when we use base, what happens? This base, let us say I am indicating base with B minus. Okay, so now what happens is some groups must be removed from our substrate. This is our substrate, this is our reagent. So from here halide ion goes out, this is a group removed. So if it is removing, see, bonded electrons are carried out by this living group only, right? So now what is the charge created on the carbon? Positive charge. See, carbon is getting positive charge. Now what happens is, from the adjacent carbon, if there is any weak bond, that bond will break and that electrons are given to the carbon. Okay, so here carbon-carbon bond is very stronger, it cannot be broken, but carbon-hydrogen bond is relatively weaker, so that bond will be broken here and that electrons can be donated to the adjacent carbocation like this. Okay, so now how this H is removed? See, just H plus is removed from here now, because bonded electrons are moving this side. It means that this base will abstract this proton. What this base will do? Abstract this H plus proton only. Okay, and the sigma electrons between the CH will be shifted to the carbon, adjacent carbon. Okay, the halogen attached carbon is there now, that carbon is called alpha carbon and the adjacent carbon is called beta carbon. So from what are the sites we are removing the groups? From alpha and beta position now. So you can say this is alpha beta elimination. What you can say? Alpha beta elimination or 1, 2 elimination. This is 1, this is 2. 1, 2 elimination. One of the important concept to be understood here. 1, 2 elimination. So what is a product formula? Tell me. See, you are getting C and C. One hydrogen already present. Here one more hydrogen is there. There is one CH3 group. I am writing as it is, and this is one CH3 group. Okay, so you remove this proton and this leaving group, and you are getting a double bond over here like this. Right now, so you are finally getting an alkene. Let me rewrite this alkene. Let me rewrite again. Once again, I am writing this. See, carbon, carbon, hydrogen, hydrogen, CH3, CH3. That's it. So by alpha beta elimination, what type of products are formed? Alkenes are formed as a product. What are the products formed? Alkene will be a product in alpha beta elimination. Okay, so is this clear or not, whatever we discussed? Okay, is this clear now? Clear, 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 right? Yeah. Yeah, so let us discuss few more things. This is clear now. Sir, you are directly saying 1, 2 elimination. Is there anything like 1, 1 elimination? Yes, there is alpha alpha elimination also, alpha beta elimination is there, and alpha gamma elimination also there. But more specifically, we need to discuss about alpha beta, that is 1, 2 elimination only. Okay, I will tell you 1, 1 elimination, one best example we have, and we will be using that in the upcoming reactions also. Like there is something called Reamer-Teamer reaction, there will be using 1, 1 elimination. What do we mean by 1, 1 elimination? See, it is very easy to understand. 1, 2 means we are removing from 2 adjacent carbons. It's 1, 1 means from the same carbon only we are removing 2 groups. Let us see here what I am writing. So CHCl3, chloroform I am writing. So chloroform, CHCl3 is called chloroform. So from this, once again see what I am writing, CCl3 and here H, chloroform only, no, right. So I am using a base here, OH minus, let us say it's a base abstracting this proton. Now if it is abstracting proton, the bonded electrons will be stays with the carbon only, right? So you are going to get a carbon negative charge, chlorine, 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 like this. See, carbon is a very small atom and chlorines are more electronegative atoms here, right now. And carbon cannot hold that negative charge, okay, negative charge cannot be held here because these electronegative atoms are there now. There will be some repulsions you can expect between lone pairs and the negative charge of carbon. So now what happens is chloride ions can goes out easily as they are more electronegative, they will take the bonded electrons with them only, and what they are giving now, Cl, if one chloride ion is going out, you are getting this negatively charged electrons are there here, negatively charged electrons are there here, and you are creating one vacant orbital also because it is going out. So from the same carbon only, from only this carbon only you removed proton and you removed one halide right now. So it means it is eliminating from only one carbon now, same carbon now. So you can say alpha alpha elimination or 1 comma 1 elimination. Okay. So the product formed here is called carbene. What is the product name? Carbene. So there is 2 carbons now. So you can say dichlorocarbene. What you can say? Dichlorocarbene. Okay. This is an intermediate in a Reamer-Teamer reaction, RTR reaction. We will discuss about that later, but remember this, dichlorocarbene is a product formed in this chloroform 1 comma 1 elimination. Okay, is this clear whatever we discussed? Right, let me explain few more things. So you got about 1 comma 1 elimination and 1 comma 2 alpha beta elimination. So at this alpha beta elimination we have further classification, that is E1 elimination, E2 elimination, and one more thing is called E1 CB elimination. Okay, let us first understand this E1 and E2. Okay, let me explain you about E1 elimination first. So E1 elimination, see, similar to SN1 reaction. So the rate of reaction depends only on substrate concentration, not on the base. Okay. So during the elimination reaction, what is happening? Tell me. So there is a usage of base that is abstracting a proton, and that will be making an alpha beta unsaturated product will be getting like this, like a bond, a pi bond is forming. Okay, alkene. So we can say unsaturated compound is formed right now. So again, if you observe, there is only one substrate, but product side if you see, you will get one product as well as you are removing HX now. So you are getting something like HX. So product side you have 2 particles, when it comes to reactant side only 1 particle is there. So the number of particles product side is more now. So during the reaction entropy increases. During the elimination reaction entropy will be positive, delta H delta S will be positive. Okay, so here delta S is positive. So in order to make this as a spontaneous reaction, we have something called delta G is equals to delta H minus T delta S. Okay, so for this process, for any spontaneous process, delta G should be negative. What I am saying, delta G should be negative. Okay, and this is an endothermic process. The removal, this elimination reaction is endothermic process. It means delta H is positive, and here delta S also positive only right now, because number of particles are more the number of particles, more is a disorderness. More is a disorderness means more spontaneously it happens. Why? I will tell you. See, so for a spontaneous process we need to make delta G to be negative. In order to make it negative, we already having a fixed value, that is delta H as positive. So if it is positive, this won't make the reaction more spontaneous. But if you see, T minus is there here, T delta S is there. So if this second term is dominating, because here negative symbol is there, this is positive, positive into negative, it will be negative. If this second term is more dominating, then our delta G become more negative right now. If this second term is dominating, then delta G becomes more negative, because a negative symbol is there here. See, in order to more dominating second factor, this second term, what we can do? Yes, we can increase the temperature. Yes, if you increase the temperature, more is the temperature, more will be the negative part, it will become more negative part, means more is a negative delta G. Okay, so it means elimination reactions are favored by high temperatures. What it will be favored by? It will be favored by very high temperature. Okay, so normally if I talk about substitution reactions, yes, they will be happens at even normal temperature also, but elimination reactions are more preferable at high temperatures. Remember this factor, very important factor it is. Okay, next. So during the elimination reactions, what I am writing, similar to substitution reaction, I am writing here tertiary alkyl halides, tertiary alcohols more reactive than secondary alkyl halides, secondary alcohols, you can remember. And then primary. So this is a reactivity order. Okay, so the rate of reaction depends only on substrate concentration, not on base concentration, only substrate concentration in case of E1 elimination reaction. Okay, so now intermediate formed, this is a non-concerted, this is also non-concerted reaction, it is also non-concerted reaction. Okay, so the intermediate formed here is carbocation, carbocation is an intermediate formed. Okay, the next one is carbocation is an intermediate formed. Carbocation is an intermediate formed. Okay, so that's why if carbocation intermediate is formed, we know tertiary carbocations are more stable than secondary than primary. That's why this is the reactivity order for E1 elimination. Okay, remember like SN1 reaction only. And you can remember one more statement, even in E2 elimination also reactivity order will be same. Okay, we will discuss about that, what are the factors deciding the product and how and why the tertiary alkyl halide is more reactive than secondary. I will explain everything, just be connected to these sessions every day. Okay, so even I will be discussing only till E1 reaction today, we will be continuing further about the E2 and their applications in the upcoming session. Just connect to this channel every day and make your preparation more productive. See guys, the same content will be there even for any other courses also. Okay, so just what I am saying, you just try to use this this content whatever we are sharing here for making your preparation more productive and effective. Okay, and I am making it as much as simple as you can follow the session. Okay, and there is no other stupid discussions or emotional downing the students. I am just giving you the pure content. If you like the content, yes, follow the sessions. Okay, if you have any confusions or any difficulty in understanding the concept, just write in the chat box. I will make it clear in the upcoming sessions. Okay, that is the only thing we will be sharing from our side. And if you like this content, please share with your friends who are preparing for this kind of exams like JEE, NEET, EAPCET, whoever preparing, please share with them. Okay, right. And if you wanted to, in case if you wanted to join any of our paid courses, so you just contact us to the mobile numbers provided in the description box or on the page of this channel. Okay, that's it. Okay, you can feel free to talk with us even on phone calls by contacting the mobile numbers given on the description box or on the like a page, main page of this channel. Okay, right. Let us move forward with few more discussions on this. So it's a non-concerted reaction. Carbocation is an intermediate formed during the reaction. Okay, let us take one reaction to understand this. So CH3, some R group is there. R group means that is also alkyl group only, like ethyl, methyl, anything you can take. So here one halide ion I am taking, or hydrogen atom I am taking, and here I am taking one halide ion. So now what happens, tell me, during the reaction? So can you tell me whether this is carbon tertiary halide or not? Yes, this is a tertiary halide. So you need to treat this with a KOH. Okay, again remember guys, whatever the base you are taking, that base should have more basic nature. Okay, yes, definitely if you take any negative charged species like this, say this can have two abilities. It can act as a base or it can act as a nucleophile. So when we say it is a base, if it is abstracting a proton, acting on a proton, then you can say it's a base. If it is abstracting or acting or attacking any electron deficient sites, then you can say it's an electrophile. Okay, this is a small or major difference between a base and a nucleophile. Okay, so in these elimination reactions, it should act as a base. It means it should abstract the proton, not attacking on the carbon. If it is attacking on this carbon, it becomes a substitution reaction, right? So it should be abstract a proton, adjacent proton to this living group. Okay, so now what happens is this KOH should be taken in alcoholic medium. Alcoholic KOH should be taken. If you take aqueous medium, what happens in aqueous medium? It will be substitution takes place. It favors substitution because in aqueous medium it will be having more nucleophilic nature. Okay, whereas in alcoholic medium, here strong basic nature will be there. And guys, one more thing, in SN2 reaction we discussed now, so the solvent favors SN2 reaction is polar aprotic solvent, you remember, whereas SN1 reaction I discussed in the last class as polar protic, and this will be polar aprotic. Okay, listen here for this elimination reaction here. And what I told you, heating conditions favors elimination reaction. So this is the standard representation of reaction. So now what happens here is in E1 elimination, similar to SN1 reaction, first halide ion goes out, like whatever the living group is there, that comes out first. When it is coming out, it will be creating a positive charge on this carbon, right? So write the thing formed here, CH3, a positive charge on the carbon, and here CH3, hydrogen over here, and our alkyl group over here. That's it. Next, what happens? Tell me. This is a tertiary carbon. Check once. This is a tertiary carbon, right? See, methyl group, and a carbon. This is a tertiary carbon. Now, what happens? This is a stable carbocation, right? So, tertiary carbon. To this adjacent carbon is there now. On that we have hydrogen. So, that is the only weaker bond we have. So, KOH, this base, abstract this proton. Okay, I am writing base here, alcoholic KOH we are writing now. So this base abstract this proton. Okay, so you might be having, sir, why we are using alcoholic base? See, alcohol means, let us say ROH is an alcohol. Okay, now we are treating this with base. Now what happens? You are going to get an alkoxide ion. So alkoxide ion is a stronger base here. Okay, that will abstract this proton effectively. So that's why it will be basic nature increases. KOH will be shows basic nature in alcoholic medium. That's it. Okay, so under heating condition, what it will do? It will abstract this proton, and this sigma bond will be shifting over here. So you will get carbon CH3, bond here CH3, and here R group, and a double bond over here. That's it. This is the alkene formed as your product. Okay, is this clear or not? Yes, guys. If this is clear, click on the like button who are following the session. Right. Next thing is, I need to discuss about E1, E2. These are the points to be remembered. In elimination reactions, that is unimolecular, that is E1 elimination reaction, it is a two-step process. First step is carbocation formation, that is a rate determining step. Reactivity of alkyl halide 3, 2, 1 I told you, and here there is no point of discussing about weak base, a strong base in E1 elimination. Why there is no point of discussing? Because in rate determining step that we discussed here, the rate determining step, base is not involving, only substrate is involving, that this is a rate determining slowest step. Okay, so that's why we are saying rate of reaction depends only on concentration of base, concentration of substrate, not on the base right now. So that's why whatever the base you are using, the reaction proceeds here. So now you might be having some confusion between how to differentiate SN1 reaction and E1 reaction. Yes, we are going to understand that in the upcoming session. No worries about that. And the next here, next point is polar protic solvent favors E1 elimination. Even SN1 reaction also favored by polar protic solvent only. And 4 product formed will follow Sage-Jaffe rule. What is this Sage-Jaffe rule? Internal alkenes are more stable. I will tell you about this Sage-Jaffe rule also in the upcoming session. Okay, and right now let us solve 1 or 2 questions. I will check whether any question is there in these slides related to SN1 and SN2 reactions. So there is no exactly, but I have one neat question, like remaining are there, like lot of questions are there, but we will solve all together by once after studying E1 and E2, then after comparing this E1, E2 with SN1 and SN2, then we will solve all the levels of question, whether it can be JEE mains, JEE advanced, NEET, JEE, whatever the exam, we will solve once after understanding the question. Okay, right. Look at this. Elimination of 2-bromopentane to form pent-2-ene. So from 2-bromopentane, this is a pentane. Okay, 1, 2, 3, 4, 5 are there. So 2-bromo, here bromine is there. So this will be involving in elimination reaction to form pent-ene, pent-2-ene, like this it is forming. So what is happening here? So from this bromine is removed. From here, from internal side we are removing hydrogen. See, for this carbon, this is alpha, consider this is also beta, and this methyl group also beta, right now. So this hydrogen can also be beta protons. So you can remove beta proton from here and can from here, but specifically they are mentioned it is pent-2-ene. It means internal proton is removed, because internal alkenes are more stable by hyperconjugation compared with the terminal alkenes. So this type of products, just now I mentioned, what we can call them as Sage-Jaffe product. What you can call Sage-Jaffe product. You can call them as Sage-Jaffe product. Okay. So it is following beta elimination. That is what alpha beta I told now. That is also called as beta elimination reactions, and it follows Sage-Jaffe rule. What it is following? Sage-Jaffe rule. Okay. So tell me whether it is dehydrohalogenation reaction or not. See, we are removing. See, if I remove proton, you should say deprotonation. Here we are removing halogen as well as proton. So hydrogen if you removing, dehydrogenation. Halogen also removing, dehalogenation. Both together you are removing dehydrohalogenation. Yes, even third C also correct. If you are removing water, see, we are saying general words also, dehydration, that fellow is getting dehydrated, we will say now. Okay, so dehydration means what? Removal of water. But here we are not removing water, we are removing H and Br. So it is a dehydrohalogenation reaction. So A, B, C are perfect. So where do we have A, B, C? Fourth option will be the perfect answer for the question. Hope the discussion is clear. Now try to solve questions related to related to SN1, SN2, E1, and by the next session we will be coming up for E2 elimination and comparisons between E1, E2, and SN1, SN2. Okay, so the PYQs related to that will be discussed in the upcoming session. Now, whatever we discussed, I will be providing few few PYQs. Just try to answer me them in the chat box. This is first question I am giving you. What are the perfect answer for this? This is one more question I am giving you, and this one also, and this one also. All these questions are for your practice purpose. Tell me answers for this question in the chat box. So thanks for watching. Stay connected with our NEET World channel. Thank you.